Welcome back. All right, today's lesson is just a continuation of how our unit started last week. We talked about quadratic functions in terms of what is a quadratic. The quadratic is just simply any equation with the highest exponent of a square. If your highest exponent is a 2, that is a quadratic. It could look like this, it could look like this, it could look like this. You could have ax squared plus b of x plus c. You could have ax squared plus c. It doesn't matter. A quadratic has to have an x squared as the biggest exponent, okay? So today is 10.2. I'm not gonna write on the board, but today's lesson is 10.2. If you need a name, just quadratic functions is fine, okay? We're gonna be talking about how to graph quadratic equations, because last class when we talked about graphing quadratic equations, we only did y equals ax squared and y equals ax squared plus c. Those are the only equations that we graphed. We have not talked about how to graph y equals ax squared plus b of x plus c. We have not talked about how to graph this. Well, that's what we're doing today. We're going to be graphing equations that have those 3 full terms, okay? So, 10.2 quadratic functions. Let's figure this out here. Example number 1. We have y equals negative 3x squared plus 6x plus 5. Okay, so we have to graph. We gotta graph this, okay? So, first off, how can we find the vertex? Because that's the first thing you're gonna do. First thing, find the vertex. So, how can we find the vertex? Well, guess what? There's a pretty easy formula to find out what the x-coordinate of a vertex is. It is simply negative b over 2a. That is how you find the x value in your vertex. So for this one, my negative b value, b is 6. So this becomes negative 6 over 2. My a value is negative 3. I get negative 6 over negative 6, which just becomes 1. So my x value is 1. So now I need to find out what my y value would be. And simply how I do that is I plug in 1 and find out what it equals. So negative 3 times 1 squared plus 6 times 1 plus 5. Okay? So 1 squared is 1 times negative 3 is negative 3 plus 6 plus 5. Okay? So basically 11 minus 3, 8. So my point is 1/8. This is my vertex. My vertex is 1/8. Okay? So then when we go to graph it, let's do it over here. Go to graph it. 1, 2, 3, 4, 5, 6, 7, 8. 1/8. There's my vertex. Okay? Now, this is the same as last class. Put a point on each side of that vertex and find your value. So for this instance, let me switch colors. I'm going to plug in 0 and 2. Okay? If I plug 0 into the equation, anything times 0 is 0. So this is going to be 0. This is going to be 0. It's just left me with basically negative 3, and I'll write it out so you can see it, plus 6 times 0, plus 5. Okay? Like I said, anything times 0 is going to be 0. Anything times 0 is going to be 0. 5. So my point is going to be 0, 5. So I can come over here, 0, 1, 2, 3, 4, 5. Okay? Now I need to plug in 2. I need to go on the other side of the 1 of the vertex. So I can take negative 3 times 2 squared plus 6 times 2 plus 5. 2 squared is 4. 4 times negative 3 is negative 12. 6 times 2, 12. Plus 5, These cancel out. What I'm left with is 5. My point is then 2, 5. So I can come over here, point 2, up 5. There you go. There's my parabola. Okay? So, you found the vertex, you found 2 points. The last thing you need to do is find the axis of symmetry. Remember, the axis of symmetry is simply like the middle point, the middle line. If I were to fold the parabola on this line, they would match up touching, okay? So, what's my center point? Well, my axis of symmetry is just, like I said, down the vertex, it would split the parabola in half. So in this case, the way to write a vertical line at a certain x coordinate, because remember, this is my x coordinates, so x, this is 1. The way to write a vertical line is simply x equals 1. That is a vertical line. That is your axis of symmetry. So if it says graph the equation, find the axis of symmetry, or graph the equation, typically you're just going to want the axis of symmetry as well. So you should have the parabola plus your axis of symmetry. And that's about it, okay, for that first example. Let's go to the next part. That's the same thing, but we'll do it anyways. Get you another practice problem. All right, so our new equation. Your new equation, your graphing, is y equals x squared minus 4x plus 1. Okay, that's our equation. So, let's graph it. Vertex, how to get the x coordinate? Negative b. My negative b is negative 4. So this becomes negative 4 over 2 times a, which is 1. This is going to give me 4 over 2, or 2. So my coordinate becomes 2, 2 comma. We got to find out the y value. Well, let's plug 2 in. 2 squared. 2 squared minus 4 times 2 plus 1. 2 squared is 4 minus 4 plus 1 cancels out. I get 1. My vertex is 2, 1. That's my vertex. So if I have this graph, over 2, up 1, there's my vertex. All right, so we have the vertex. Now, we just need to find 2 points. We gotta go on the left or the right. So, I'm gonna plug in, let's see, I'm gonna go with 0, because I think 0 is super easy. 0 squared is 0, 4 times 0 is 0. So it's just gonna leave me with 0, or y equals 1, okay? Because 0 squared is 0. Negative 4 times 0 is 0. All I'm left with is plus 1, so y equals 1. So this point becomes 0, 1, okay? So, over 0, up 1. That cannot be right. Did we mess up our vertex? Negative b becomes positive 4. 2 times a is 2. We find 2 squared. Oh, 4 times 2, there we go, plus 1. So, 4 minus 8 plus 1. My apologies. So, 4 minus 8 is negative 4, plus 1 is negative 3. There we go. My point is 2, negative 3. So I come over here, I fix this. 1, 2, 3, 2, negative 3. Okay, there we go. All right, so we have that fixed. Now we can plug in, I put 0 in, it becomes 0, 1. So 0 up 1. Okay, and now I'm going to do 4. So 4 squared minus 4 times 4 plus 1. Okay, 4 squared is 16 minus 16 plus 1. These cancel out. I'm left with 1. My point is 4, 1. 4, 1. There you go. There's my parabola. Again, don't forget your axis of symmetry. My axis of symmetry is going to come right down here. I'm left with x equals 2. There's my axis of symmetry. Okay? Hopefully that makes sense. Sorry about this mistake. If you're seeing this, I'm more than likely fast-forwarded through this since I made a mistake. Maybe not. Okay, so we've done that. Now let's talk about graphing quadratic inequalities. So, get ready for your next set of notes. This is just example 2, or basically, I'm trying to think of how to phrase this. Concept number 2. We're going to be learning a new concept because we're done with functions. We're going to do inequalities. Okay, so like I was saying, concept number 2, graphing quadratic inequalities. Okay, you know what an inequality is. An inequality, you've probably seen it 100 times before. Greater than, less than, greater than or equal to, less than or equal to. Okay? You should know what those are. You should have seen those in the past. Okay? So, how can we graph these? Well, let's talk about it. Here's your practice, or your example. Y is greater than or equal to x squared plus 4x minus 3. Okay? In terms of how to get the graph, that's the exact same thing as what we've been doing. So, how do I get my vertex? Negative b. So negative 4 over 2 times 1 is 1, or 2 times 1. So then I get negative 4 over 2, which becomes negative 2. Okay, so my coordinate becomes negative 2. Plug in negative 2, I get negative 2 times, or negative 2 squared, which is 4. Negative 2 times 4 is negative 8, minus 3. Okay, so 4 minus 8 is negative 4, minus 3 is going to be negative 7. And this is a bad marker. Okay, so let's graph it. What does this look like? So it's 2 over, and it's 7 down. 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. So 7 down, 2 over. Okay, so there's my vertex. Again, find 2 points. 2 on the left, or 1 on the left, 1 on the right. So I'm putting 0 in. Again, 0 is easy. 0 squared, 0. Plus 4 times 0, 0. Minus 3. My point is 0, negative 3. Okay? Plugged in 0, and I get negative 3. 0 squared, 0. Plus 4 times 0, 0. So 0 plus 0 minus 3, negative 3. Okay? And then I'm going to do, let's do 4. So 4 squared is 16 plus 4. Well, this is a my bad. This is a negative 4, still gonna be 16. Okay, and then 4 times negative 4, which is gonna be negative 16. And then minus 3, these cancel out. I'm left with negative 3. So I get 4, negative 3. Negative 4, negative 3. So 3, 4, 2. There you go. Okay, here's where things get different. Luckily for us, it has an equal to sign. And I say lucky for us because if it's one of these two, if there's an equal sign underneath, this is a solid line. Your graph is a solid line. If it doesn't have an equal sign, then it is a dotted line. Okay, so if this was y is greater than, well now all of a sudden it looks like this. It's a dotted line. It's not one solid black line. It's got gaps in it, okay? But if it has a line underneath, meaning greater than or equal to, less than or equal to, it's a solid line. Why is that? Because what that means is that anything that the line goes through can be a solution. You can have, what do we say? Negative 4, negative 3. Negative 4, negative 3 is an answer with a solid line because it can include numbers on the line. With a dotted line or just a greater than or equal to sign, then all of a sudden you can't use values on that line because it's not greater than, it's equal to. Okay? So I'm going to fill that back in so we don't forget anything. Okay, so we have our solid line. Now, the last thing we have to do with inequalities is shade. How do you shade? Super easy. Pick a value somewhere. So I'm going to pick 0, 0. I put 0 in for my y, and then I put 0 in for my x's and I solve. 0 squared, well, that's 0. 4 times 0 is 0. Minus 3 is negative 3. So what I get is 0 is greater than or equal to negative 3. Is that a true statement? Is 0 greater than or equal to negative 3? Yeah, it's greater than. So what does that mean? It means that I shade the area that has that value included. So on this, 0, 0 is inside of my parabola. So I can shade the inside of my parabola. Okay? If I plugged in 0, 0 and I got 0 is greater than or equal to 10, meaning that's not true, I would have shaded the outside of my parabola and left the inside blank. Okay? You are shading, it doesn't matter what point you pick. I always just think 0, 0 is super easy to do. If it is inside the parabola and it is a true statement, you shade inside the parabola. If you pick a coordinate outside the parabola and it is a true statement, shade the outside of the parabola. If you shade it and you get the wrong answer, then shade the opposite of what you picked. Okay, so if I picked 5, negative 1, so right here, if I picked 5, negative 1 and plugged it in for x and y's and got a statement that wasn't true, which would happen, if I picked this point and it wasn't a true statement, then I shade the opposite. So instead of shading out here because it was wrong, I shade inside because it was wrong. You only shade the part if it's right. Okay? Hopefully that makes sense. I can't do much more to make that clear. As usual, if you have questions, ask me, ask another teacher. Use your book. This is all in the green book. Your assignment's in the green book. These notes are from the green book. Okay? Check the green book if you're confused. Ask another math teacher. Ask Mr. Rigby, I think is going to be back tomorrow. Or pull up a YouTube video. Look up on the internet. But hopefully this will suffice. Okay? Just make sure we're making sure that we're paying attention to the sign. If it's underlined, that means or equal to. And yeah, I don't think I have anything else for this, okay? Let me know if you have any questions. Shoot me an email. I should have my laptop with me tomorrow. But yeah, have a good one. Peace.